Today we're going to do our notes on projectile motion. There is a typo. Fix this right away. It's at the HT equation. It should have said -1/2 GT squared. That was my bad. Pretty much a projectile is anything like a ball, an arrow, missiles, or stones, anything that you could throw or shoot, fire. If it goes up in the air, as it goes up, it slows down in speed. Then it gets to its highest position. Then as it falls, it comes down faster and faster and faster. There's one thing about a quadratic equation. It's an equation for height. And if you calculate the h, you can find the height at 1 second, the height at 2 seconds, the height at 3 seconds, and so forth. And it will tell you where that ball is or where that projectile is at any point during its arc, during its trajectory. All right. G is gravity. V sub 0. Now that's your initial velocity. There's lots and lots of velocities. But the one that we start with, the V sub 0, is your start velocity. H sub 0 is your starting height. Okay? So you'll find those numbers from the middle, be a number at the end. I tried to go online and pull things that would give you good examples. All right. So, look at the examples that I have up here. This one shows a cannon. Now, the cannon is just shooting the object straight out. But when it goes out and down in a smooth parabola-shaped trajectory. Well, this picture and the second picture are separate. But this just gives you different examples that all have a particular parabola shape. The pathway of a projectile motion is always in the shape of a... In the first picture. From the first picture to the second picture, this one shows, I mean, it's very, very slight. I hate when I do that. It's very slight, but that follows a very simple parabola. This middle picture here kind of models, if you were trying to play catch and your friend hadn't shown up yet and you just toss it straight up in the air and then you try to catch it, that would be the second one. So the parabola is very tall and skinny, but it still follows that curved parabola shape. And then, of course, this one, if you toss the ball maybe to someone else, definitely a parabola. So these are all projectiles. They all have that quadratic parabola shape. Okay, our first example. We need to write the equation. Notice I did not write it for you. But I kind of gave you the blueprint for what it looks like. So go back a couple of slides, and at the top of your notes, here is that blueprint I was talking about. So my equation tells me the height at any time. That's why it says H parentheses T, the height at any time. So all I have to do is try to find the time across through here. So H of T, now it says 1/2 and it's negative. Now why is gravity negative? Because gravity always acts in what direction? Down. So it's negative 1/2 of gravity. Now, I'm going to use meters per second or meters per second squared. Now the reason that there's 2 seconds is because it's mentioned twice. You're going to speed up or slow down 10 meters simply. 9.8 is really close to 10, right? That's 9.8 or 10 meters per second each second that goes by. So 1 second after you drop yourself, or if you fell off a cliff, or if you dropped a penny or any object, 1 second later you would be going at a speed of 10 meters per second. But you're not going to stay at 10 meters per second, 10 meters per second. You're going to speed up an extra 10 meters per second each second that goes by. So at the end of the second, you would have gained another 10. Now how fast are you going? Well, at 0, then you'd be 10. Then at 2 seconds, you'd be to 20. At 3 seconds, you would have picked up another 10 meters per second. So each second that goes by, you're gaining an extra 10 meters per second of speed. That's what that means. If you were talking about feet, like if you're in the English measuring system instead of the metric system, you know, a meter stick is about as long as a yardstick, right? So about how many feet is in a yard? 3, exact. And about a little over 3 would be in a meter stick, right? So it converts to like 32 feet per second, or 32 feet per second square. Now, I know you guys are already familiar with acceleration units because I've heard some of you say meters per second square, which is meters per second per second. And I always like to break it down and say meters per second each second, because that way you kind of understand that it means that you're actually speeding up or slowing down. So if we simply break that down into 10, what's negative half of this gravity value? What's negative half of 10? So my would be negative 5 t squared. We're writing our own equation. That was our blueprint. Then it says plus v sub 0 t. How fast did I show you or tell you that you're going to push that ball off to begin with? I see 2 other numbers. I see 3 meters above the ground, velocity of 14. So the next would be plus 14 times t. Then it says plus, and what's the number at the end? The number at the end is your starting height, and how tall are we starting? 3. All right, does everybody know? We wrote our own equation starting with that blueprint. Of course, negative 5 just makes it nice and easy. And this one's actually going to factor. What is the height of a ball that's hit the ground? It is a trick question. 0. So if you started here and you hit the ball and it hits the ground, it has a position of 0 because it doesn't have any height off the ground at all. Okay, so what I'm going to do is if I copy my equation, and then we say, when does the ball hit the ground? Well, now I know that the starting height, or actually the ending height, at any time is now 0. Negative 5 t squared plus 14t plus 3. Basically, I've set this equal to 0. Do you remember what we called it whenever we were trying to find where a parabola crosses the x-axis? What do we call these places? They were called x-intercepts, or what else? No, x-intercepts or zeros, roots, or solutions. So the same thing that we did in the last unit, we're just now kind of making it more specific things, okay? So now we're going to say, where does it hit the ground? There's also one more thing I tried to pull out when you viewed that video, is we don't really need all 4 quadrants, do we? We really only need what? The top right, because in the real world, now, there are going to be some questions toward the end where it may say, let's just say there was a lake out here. Could the ball fall down under the level of where it started? Yeah. It could fall like in the water. But for most of our problems, once it hits the ground, it's not going to dig its way in the earth. Okay? So that's why we're kind of going to restrict ourselves to only needing the top right-hand quadrant. But we're still solving for zeros. First thing I have to notice is I cannot factor easily if I have a negative first term. So what I'm going to do is I'm going to divide out that negative. So let's divide out everything by negative 1. It's legal as long as everything gets divided by negative 1. And pretty much all that essentially does is it changes all of my signs. 0 divided by negative 1 still is 0. Negative divided by negative is positive. That becomes negative, and this becomes negative. Guys, that factors. And it's one of those that we have to check inners and outers in order to be sure that we have it factored. But it's kind of easy because there's only one way to factor 5t squared. 5t and t. Or if you like x, you can use x. It's the only way to factor 3. 1 times 3. Now, if the last term is negative, we're going to mentally what? Subtract to get the middle. So where do you want your 3? In the first parenthesis or the second one? Let's put it in the second. So if you check, mentally check, 15t, and then this would be, if I put a 1 here, it would be what? 1t. Which one, the bigger number wins the sign, right? So the middle sign is negative, so 15 needs to be negative, and 1 needs to be what? Okay, trace back over where the 1 goes, so I need a what? Plus and minus. Is everybody good? We are solving by factoring, which is old. These are old skills. These are skills that we already know. We're ready to split. Now what do we do? Set each one equal to 0. So set 5t plus 1 equal to 0. If you move the plus 1 over, it becomes what? Negative 1. Then if you divide out the 5, I think negative 1 divided by 5 is like 0.2. So it's negative 0.2. Kind of doesn't make sense. What about this answer? What's t minus 3 equal to 0? Okay. Now, everybody good with that? Which one of these answers is going to be our legitimate answer? When does the ball hit the ground? 3 seconds. Now this actually tells me, it confirms for me, doesn't this thing already start like 3 meters off the ground? Okay, or I guess it'd be 3 meters off the ground. So maybe it's a basketball player shooting it or whatever this ball is, but it says it's thrown. But if you're already at some height, if you projected it backwards, back to that negative side, that's really the part we would never see. Okay? So we're going to discard the negative because you can't have negative times, and our answer is truly the positive. Everybody good with part C? All right. Grab your calculators. You grab yours, I'll grab mine. Okay, let's go to y equals. Okay, take a minute. I want you to be sure that you go back to the original start equation, not the one we solved. This would not give us the parabola I need. Negative 5t squared, only we don't have t's, we're going to use x's, plus 14x plus 3. Everybody type it in. Huh? We are getting ready to, yes. What is it? Yes. We just solved for those same answers. Okay. All right. We have a couple of more questions that we're going to use the calculator to answer. But remember what I said a while ago? You can solve a lot of these problems with your calculator if you know what function. Sometimes it's a maximum. Sometimes it's intersection. Sometimes it's 0. Depends on what they ask you. Is everybody good? You got it in. Okay, let me go to the next page. Let me clear that out. Okay. First thing I want you to do is I want you to understand that you're going to be looking at a graph that starts where? So you draw it, I'll draw it. Let's sketch it out. It doesn't start at 1. I'm talking about the y-axis. What was the starting height? The starting height was 3, wasn't it? Okay. And we know this thing is going to go up, and it's going to do what? All right. At what time will it touch the ground? Should be at what? 3 seconds. Does everybody understand? So we're just sketching it. And our goal is, I guess I should have drawn that in solid colors. That would have been a little easier. Let me take that off. Oh, there we go. Okay, so 3 seconds. The part that we can't see, this would have actually been the what? Would that have been the negative 0.2? That would have been the one, of course, that's the one that we do not see in the real world. Okay. Type the original equation to y1. Adjust your window until you see the path of the ball in a good viewing window. When does the ball achieve its maximum height, and what is the maximum height? Okay. It's fine. Everybody good? Okay. We're going to change our viewing window. Okay, go to window button. Mine is on a standard window. For the real world, do I need anything in negatives? No. Now remember, X stands for what? Those are in seconds. Those are time numbers. So I'm going to start at 0 seconds, and I know it's going to go to 3. If you want to go, usually I go a little bit more. Sometimes I may go 4 just so I can see it really well. 3 is fine. Now, do we know yet how tall it's going to be? Not yet. I know 0 is the lowest, so y minimum is 0. All you need to do to begin with is just pick a number Guys, 14 as a speed is not tremendously high. Like you could probably toss a ball 14 meters per second. Like a bullet is hundreds of meters per second. So we're not talking anything that's going to go tremendously high. So let's pick a reasonable number. Give me a number. 10. Well, it's already at 10. 15. Have you already checked it out? All right. They've chosen 15, and apparently this ball does not get any higher than 15. If you can see the full parabola, you have chosen good numbers. Now, what if we had just left it at 10? What if you had chosen a number and your parabola looked like that? Then you would need to go to a higher y number. So you would want to change your y maximum. So it's about learning to manipulate your screen until you get a better picture. If you had done 20, you would have found it. It's not 13. I want a more exact answer than that. Okay. It says, when will it get to the maximum height, and what is the maximum height? Hit your trace key. Everyone hit your trace key. Trace till you get to the highest y value possible. Is 12.71767879. Okay. Now this is going to be a process very similar to 0. I tried to put your steps down here. We're going to use second trace. We're going to use number 4 maximum. Okay. We're going to go left 3 enter, right 6 enter, and enter once more. See what you get. Second calc, which is trace. Second trace, which is calc. Number 4 is the maximum. Left bound. What do you do? 1, 2, 3, enter. Right 6. It's got a glitch and it kills me when it does that. All right. Did it give you an exact answer? Okay, what's the answer to question D? When does the ball achieve its maximum height? Okay. Now, does everybody understand what you're viewing here? Your x values are your time numbers. So that's 1.4 seconds. The y numbers are what? Height. So that's 12.8 meters. So my answer to part D is 1.4 seconds, because that's my x value. X values are time numbers. And then the maximum height is at what? 12.8 meters. I do like to see you use units where it's appropriate, and you do have them, so let's use them, which is the y value, because y values are height numbers. So you just have to make sure that you understand what it is you get when you go across that viewing window. So this maximum height right here occurred at 1.4, comma 12.8. Is everybody good? Okay. Okay, let's go to the next. We're going to do problems 1 and 2, and I'm going to stop and assign. I'm going to pick and choose a few of the next ones for you to do. Okay? A lot of these you can do with your calculator. Sometimes you don't have to always use your calculator. Everybody ready? Number 1, a soccer ball is kicked from the ground. What's the starting height if it's kicked from the ground? So h of 0 is 0. And notice that they wrote the equation and there's no number at the end. So there's not three parts, there's only 2. An initial upward velocity of 90, and notice they've already put 90 in front of the t. So the equation has been provided for you. How many seconds will it take for the ball to reach its maximum height? I need to put it in my calculator. I need to get a good viewing window, and then I need to go to the top. Is everybody good? Now I'm looking at my numbers. 90 is pretty fast. So I'm thinking it's going to go higher than 90 or higher than 50, maybe even 200. So make sure that you adjust. This is your height, right? Or excuse me, this is your speed. So in 2 seconds, it's going to be 180 feet in the air, potentially. Okay. Change your y equals negative 16t squared. So apparently these numbers are feet numbers. Shh. Clear it out. Y'all got yours in? Okay. We need a viewing window. Now, guys, this is a soccer ball. Let's be reasonable. How much time do you think is reasonable for a soccer ball to be in the air? Okay. 5 seconds would probably be, that would be a good place to start. I would never try 20. I don't think there's anybody in here who can, 1,001, 1,002 could stay in the air for 20 seconds. All right. That would be tremendous if you can. I'm going to say let's just try 5. Okay. How high do you think this ball might go? 2.2 seconds. That table would be a good thing too. Goes higher than 100. And it goes farther than 5 seconds. So I'm going to go farther and higher. Okay, I'm going to say 7 seconds and 180. Okay. Now, okay, can you see the complete parabola in your viewing window? All right, even if if you say, I could trim that off and go 6. Oh. All right, picking back up. We've adjusted our window just a little bit, just to make sure. You just have to be able to see it. So play with the numbers until you see a good image. And when you're satisfied that you like the screen that you're on and you can see the entire parabola, now you can start calculating it. How many seconds will it take for the ball to reach its maximum height? And then part B, what is the maximum height? Do you know how to do maximum? Did you trace? Okay, trace. Hit your trace key. Looks like it's second calc, number 4, maximum. Left 3, enter. Right 6. I have a glitch. Every time I hit a button too fast, it doesn't like it. 1, 2, 3, 4, 5, 6. May have to go a few extra. Did you guys figure out the max? All right. What's my answer for part A? How long will it take for the ball to reach the maximum height? Is it 126 seconds or 2.8 seconds? All right. 2.8 seconds. And what is the maximum height? Okay, 126.5. Let's keep one decimal. Well, 0.5 would actually round to what? 0.6. So 126. And that is in feet. Put your phone up. The last one, give the domain and range of the function. When we talk about domain, a domain is a set of all the what? Set of the x values. In this case, the x values are the same as your what? Your set of your time values, right? What time is the start time and what's the maximum end time for this ball to start at the ground and come back to the ground? From 0 to what? From 0 to 2.81 seconds, right? Now, I'd like to write that in a more mathy way. Remember how we write it? Okay, we're going to put letter T in the middle. The time is between, remember how we do it? We do less than to the left, less than to the right. And 0 on the left, 2.81 on the right. Can it have an equals? Is it ever exactly at 0 seconds and exactly at 2.81? Yes, it is. It does start on the ground and it does stop on the ground. So it is at those positions at those times. Everybody good? All right. So range would be what? Range is the what? The set of all the y values, but in our example, the y values are the height numbers. So we're going to put an h in the middle. Backwards, backwards. What's the lowest height? The tallest height. 0. 126.6. Can it have an equals? Yes, it is exactly on the ground, and it is exactly at 126.6. Does everybody understand how we're writing our domain and range? So they're kind of pulling back that domain and range idea from way back in chapter what, unit 2 or 3. And they're just applying it to this idea here. Everybody good? Everybody okay with this one? Are you feeling comfortable with maximum? I think the trickiest thing is being able to adjust your window to numbers where you can see it. Now, sometimes it just requires playing it. Although Miss Hannah has a wonderful suggestion. She says try the table and see where the numbers fall. That might give you some good advice. Try the table. Okay, number 2. Let's do number 2, and we're going to stop with the notes, and I'm going to give you a couple to practice on your own. Everybody good? An apple is launched directly upward at 64 feet per second. That is my start what? That is my start velocity, or what we call v sub 0, and notice that they've already plugged it in the middle. I need you to see how these equations are written because there's going to be some where they won't write them for you. And the platform is what? 80 feet high. So that is my what? That is my start height, which is h sub 0, and that number is already in there. What is the height of the apple after 3 seconds? You do not need a graph for this. You could use it, but you don't need it. No graph is necessary. You don't even have to type it in y equals if you don't want to. Remember, that's the height at any what? That's the height equation at any what? At any time. Negative 16 t squared plus 64t plus 80. If you do not want to type it in y equals, you could actually say the height at what? 3 seconds is equal to negative 16 times 3 squared plus 64 times guess what? 3, bless you, plus 80. Or you can type it in y1 equals and use the guess what? And use the table. It's totally your call, whichever way you want to do it. So this is a different question. It didn't ask me for maximum height. It didn't ask me when it hits the ground. It's saying, where is it at 3 seconds? Okay. Okay, so you can type it in. I can stay on my home screen and type it in. All right, just looking at the table, we typed it in y equals. Second graph puts me at the table. Where is it at 3 seconds? 128 feet. By the way, looking at this graph, or looking at the table, I mean, at 5 seconds, what's the position of this? 0. It means it's back on the ground. So this takes us 5 seconds to actually get back to. That's not a question that asks, but that's something we can observe. So the answer is 128 feet. All right, that's it for the notes right here.